All right, in this video, we are going to be talking about an interesting way to find square roots, and fairly quickly. We have to preface here, though, we have to know that it is a perfect square in order for this method to actually happen. Now, I haven't proved it out algebraically yet, but through all of my experiences and examples with it, it has worked. So I'm going to assume that it does work for all perfect squares to find those square roots. But again, I'm not 100% sure, but let me at least show you what the method is. So over on the right-hand side of your screen, I listed out the perfect squares up to 100. And we're going to be looking at the ones digit of each of these perfect squares. So we have 1, 4, 9, 6, 5, 6, 9, 4, 1, and 0. All of these ones digit correspond to a number squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth, all the way down to 10 squared, which is 100. And in order to really explain it, I have to show you an example real quick. So let's start out with the perfect square of 576. Now, the square root of 576 is 24. So 24 is the number that we are going to be trying to get. In order for us to do this, we're going to look at the ones digit. It's a 6. So we go over to the list of perfect squares up to 100, and we have to identify which numbers or square roots of those perfect squares give us a 6 in the ones digit. So we have 4 squared is 16, so this 6 could be a 4. Or we have 36, and the square root of that is 6, so 6 squared. So this is going to end in either a 4 or a 6. The next step here is we forget about the tens digit. We're going to forget all about that tens digit for every single method on. And we're going to look at every digit going in the greater side. So we're going to look at this 5. We're going to take the 5 and we're going to look at that list of perfect squares. We're going to figure out, okay, where does the 5 fit in the list of perfect squares, and what is the square root of the perfect square smaller than 5? So 5 would fit right in here in between the 4 and the 9, and the square root of the smaller perfect square, that's 4, is going to be 2. So we're going to be ending, or I should say starting, with a 2. So we know it's either going to be 24 or 26, but we have to determine if it's going to be ending in a 4 or ending in a 6. And the weird way to do it is we're going to take our number 2 and we're going to multiply it by the preceding number, which is 3. And that's 6. We're then going to compare the 5 that we originally started with, and is that bigger or smaller than the 6? That's what's going to tell us whether it's going to be a 4 or a 6. Well, 5 is smaller than 6, so we go with the 4. Therefore, the square root of 576 is 24. And we knew that from the start. Now again, that might be a little bit confusing, so let's go through another example. Let's talk about 1,521. Again, we're going to look at that ones digit, and it's a 1. So we're going to go to our list of perfect squares up to 100, identify which roots give us a perfect square that has a 1 to it. And it's either going to be a 1 or a 9. So this is going to end in either a 1 or a 9, but we have to determine whether it's going to be a 1 or a 9. We skip our tens digit and we look at all the remaining digits to the left. That's 15. So when we go to our list of perfect squares, we're going to figure out the perfect square smaller than those digits. So our 15 falls in between 9 and 16. So we're going to use a perfect square of 9. Take the square root of that, that gives us 3. So it's going to start with a 3. And now we have to figure out whether it's going to be a 1 or a 9. To do that, we do 3 times the next number in general, which is 4, which gives us 12. Now we compare 15 to 12. Well, 15 is bigger than 12, so we go with the 9. Therefore, the square root of 1,521 is 39. All right, let's keep on getting bigger here. Let's say we have 2,025. This one's going to be interesting because we're going to see that the ones digit is a 5. And the only root is going to be 5. So we know it has to end in a 5. So we know that for a fact. But now we have to figure out what is going to be the next digits, the bigger digits in our perfect square. So we forget about the tens and we look at 20. We say, okay, where does 20 fall in line of our perfect squares? 20 falls in between 16 and 25. So we're going to go with 16, which means we have to be in a 4. Therefore, our answer is 45. There is no choice. It has to end in a 5. So we don't have to do 4 times 5. But if we did, that gives us 20, which is what we started with. So the square root of 2025 is 45. Let's get one more example done with a big number. Let's say we have 15,129. Try it out. All right, so looking at it, we have a 9, which means we go and find all perfect squares under 100 that end in a 9. That's going to be either a 3 or a 7. We're going to skip over that tens digit, and we have 151. Well, we have to find the perfect square just short of 151, and that's 144, which the square root of that is 12. So this turns into a 12. So it's going to be 123 or 127, but we have to do some multiplication. We do 12 times the preceding number, which is 13. We do 12 times 13, which gives us 156. We compare our digits we started with, 151 to 156, and 151 is smaller than 156. Therefore, the square root of 15,129 is 123. Thanks so much for checking in. Hopefully this provided a little bit of entertainment if you didn't grasp anything from it. That's totally okay. If you have questions, please feel free to reach out, but this is pretty cool. We're starting to see that math is actually pretty fun if we allow it. So thanks so much for checking in and have a great day.